Okay, good morning, good evening, everyone. So thank you for being here. Today we're going to continue our discussion about machine learning, and we're going to use a particular package which is called FF3s, which is fast frugal trees. Okay, as the name suggests, medyo mabilis yung pag-process nito. At saka frugal, ibig sabihin nun, medyo kuripot or medyo matipid sa mga attributes na ginagamit. Okay? So if you recall, we discussed that yung decision tree, that's a type of supervised learning. Di ba sa machine learning algorithm, you have three types. You have supervised, you have unsupervised, and you have your reinforcement learning. The supervised learning, if you recall, it's a type of learning algorithm where the variables or the attributes are defined. Okay, alam natin kung ano yung mga variables natin and alam natin kung ano yung output natin. So an example of that is regression. Okay, there is a regression methods in machine learning. Also classification. Okay? So yung logistic natin dati, classification yan eh. So that's why this is called CART, C-A-R-T, classification and regression trees. Okay, so sa supervised learning, meron tayong decision tree as an example, and one part of that, one example of that are your CARTs. CART means classification and regression trees. Okay, meron pang sa unsupervised learning naman, there are several examples. Meron tayong clustering. Okay, so hopefully we'll be able to have an example at least of one unsupervised learning. Okay, so si supervised, as far as classification and regression is concerned, it works for both categorical and continuous input and output variables. Okay, ang kagandahan ng decision tree, simple siya and very intuitive, very easy to explain. Okay, kasi research says that it mimics, no? Yung pag ng decision tree, it mimics how the brain functions, how the human brain makes decision making. So parang naka-mirror siya. Parang ganun yung approach. If you take a look at decision trees, di ba, ang daling may interpret. Kung yung ganitong variable is less than this, then choose this. Otherwise, choose this. Diba, ganun mag-isip ang brain eh. Okay, they can be displayed graphically. That's one advantage. Another advantage of decision trees. And then they can easily handle qualitative predictors. Pwede rin, no? Without even creating dummy variables. Kasi if you recall sa ordinary least squares, so this is a model for multiple linear regression that's apart from machine learning. Iba yung machine learning approach. Iba yung decision trees. No? So sa decision trees, hindi ka na kailangan mag-create ng dummy variables for your categorical or qualitative predictors. Okay? However, may limitation ng decision trees. Yung predicted accuracy niya, sometimes it's not that good. Okay? Hindi siya ganun karobust. Okay? And also, very sensitive siya. Konting change lang sa data mo, mababago na yung decision tree natin. Okay. So, kasi sa decision trees, you can use all the variables, no? Tapos pwede ka mag-create ng model. Now, that is very consistent with what's the common belief that as far as good decision making is concerned, the more the better. Yun ang common accepted fact. The more the better. More data, better. More time to process your data, it's better. More information you have, better. So more is better. Yun ang folk wisdom. That's very true, for example, sa medical field. No? Yung mga doktor, pag mag-decide sila whether to do this procedure or not, they oftentimes gather information para dun sa diagnosis nila. More medical tests, whatever test that is, the better. No? So in this regard, maybe that's the case really where the more the better. Okay, sa stock market, Are you going to invest in this particular stock? So, pwedeng gawin historical data, kukunin yung data, tapos magmo-model ng returns, tapos gagawa ka ng mga robust and mga complex statistical methodology, okay? More than yung mga P-guards, etc., which could describe the past perfectly. However, ang limitation niyan, pag pag rinan na siya sa panibagong data, hindi na siya nag-work, no? Palpak na siya. Okay, kasi when we add on all the data in the past, ang nangyayari, it models even the noise. So kahit yung noise, model niya. So when sometimes we use yung mga models na ganito based on the more is better theory. Okay, tapos pag pinapredict na yung mga actual na mga data, yung data that has not yet been seen by the model, mali yung model. Okay? That's why si Giga Renzer, he espouses the belief that the less is better. So in this case, even sa data gathering, sa data ano. Okay? So one reason for that is yung overfitting syndrome. It doesn't mean that if your data is complete, no? Tapos gagamitin mo yan para i-model yung data mo, then there is a problem of overfitting. Kaya nga sabi natin dati, di ba? Ini-split natin data natin into training data and testing data. So that the model we will be creating out of the training data could be used to see if that will work with a new set of data that has not yet been seen. Ito yung ginawa natin dati sa party package at saka sa RPART. Okay? Alright, so kahit na sa ang findings sila, kahit na sa mga complex na mga statistical sophisticated models to predict stock prices, changes in stock returns, no? Nagfi-fail siya, no? Hindi niya na-outperform yung yung isang model lang na napakasimple based on index funds. And that was a research based on Malkiel in 1999. Okay. So instead of aside from the complex reason, meron ding reason na psychological. Okay? Bakit? Why is this? There are many instances when kailangan ng immediate na decision making. Hindi pa pwede yung matagal pa na decision making process. That will not do. So meron mga situations na sometimes life and death situations that the doctor, given the relatively few information that he has to do something, no? Okay, so ito yung mga scenarios where the FFT can come in very handy. See, FFT means fast and frugal trees. Okay? Developed in 1999 by Renzer and Todd. Okay? So ito, si fast and frugal trees, ang ginagawa nito, it would chop down, kunyari binigyan mo siya ng attributes or variables na, let's say, 20, 30. Ang gagawin niyan, hahanap siya ng ng very simple lang. Usually 2, 3, 4, 5 attributes. Okay? And these attributes are non-compensatory. Ano ibig sabihin ng non-compensatory? Okay, kahit madagdagan pa yung information later on, hindi na mababago yung decision. The advantage of FFTs is that they're very easy to use. Tapos ginamit na siya. No? Ito, proven by some research studies. No? Yung kay Green and Mayer in 1997. Okay, sa sa heart disease ginamit nila, no? And even for detecting depression. Okay, so these are the authors in 2013. So they used fast and frugal trees in order to determine kung itong taong to ay may symptoms ng depression. Okay? All right. So ito lang may sinabi lang dito, no? Na okay, where am I? na yung use ng FF3s, hindi siya limited. Okay? They can outpredict more complex models in non-human simulations. So this is very interesting. Kaya niyang ma-outperform even the most complex models. All right. So what we're going to do now is let's start using yung ano natin yung FFT natin, no? Sorry. Okay. All right. So ano advantage ng FFT natin yung Fast and Frugal tree? We can also see the underlying tree. So parang decision tree din siya. Okay, and then you can also compute for ito yung mga misclassification natin dati. Okay, ito yung area under the curve, false alarm rate, etc. So these are metrics that we can use in FFTs. And it can be used for both logistic and your logistic regression and your normal regression. Okay? All right. So let's start now. Install muna natin kasi hindi nyo pa na-install yan. So, pwede nyo i-load si Pacman or pwede nyo install that packages, yung FF3s. So ako, since na-install ko na siya, ila-library ko na lang siya. FF. Yan ang spelling, no? Capital F, capital F, capital T, capital, oops. Small r, no? Alright, so once you're done, paki-chat naman please para so that I know that you're ready. Okay, thank you, Tim.
Sir,
Yes.
sorry, sir, i-install ba namin, sir?
FF3s.
na
Yes.
diretso, sir?
Yeah, install nyo muna, install that packages, and then library natin.
Okay, sir.
Okay.
Sir, nag-error sa akin.
Nag-error? Dali lang. I'll just get
Yes.
water. Dali lang. Dali lang. Okay, sorry about that, class. Okay, sino may problem sa ano? Sa...
Sir, kain po.
Kayan, sige nga, stop share ako. Kayan, paki-share yung screen. Ayaw nga mag-install. Install that, walang coach. Nakalimutan mo yung coach. Dapat may coach yan. Run mo nga. Yan, okay, good. Then after that, i-library mo na siya. Okay, how about the others? Thank you, Kayan. How about the others? Na-load nyo ba si ano? Si FF3?
Okay sa akin, sir.
Okay, thank you. Okay,
Yes,
so,
sir. Okay naman.
all right, good. It looks like everybody is able to load the... Sige. I think na-load na ni Kayan, ano? Okay, all right. So this is what we'll do. Let's first check, no? Tignan mo natin FF3s. I-click nyo siya dito sa packages. And what does this do? Okay. Generate, visualize, and evaluate fast and frugal decision trees. So these are the functionalities. Tingnan muna natin yung description file. All right. FF3s. So visualize, generate, visualize, evaluate, fast and frugal. Okay, fast kasi mabilis nga siya kasi it tends to just choose yung pinaka-importante doon sa mga data, no? And then frugal siya, so matipid, no? So the main author nito is Phillips. Okay, siya yung main author. Together with, there are others, author, creator din, but I think si Phillips yung main author. All right. Okay, so yung mga functionalities niya, there are several functions. Yan, no? Ang pinaka-importante sa atin dito, ito, FF3s, main function to create and apply fast and frugal trees. Okay, ito yung gagamitin natin. Alright. So let's first see ano ba yung mga data sets makikita natin dito. Okay. So si VCD Extra, install nga rin natin. Sorry, nakalimutan ko pa install sa inyo to. Si VCD Extra. Kasi si VCD Extra, pwede natin gamitin yung so na-install ko na siya. Kaya library na lang ako. VCD Extra. Okay, so i-library ko siya. And then, merong function siya, VCD Extra. P. And then, data sets. Yan, data sets. No? This one. Data sets. Data sets, pahanapin natin yung data sets coming from package is equal to FF. Okay. I just want to see kung ano yung mga package, yung mga data sets na available. Remember, yung mga packages sa R, sometimes they come with data sets, no? Okay, let's see. Run natin to. All right. So ito yung mga data sets that come with R, with FF3s. Okay, so we have here blood, more on medical, ano? May credit approval then. 16 variables. So we're going to use this one, heart.test and heart.train. So ito, na-split na yung training data at saka testing data. So we're going to model heart.train and then later on, ilo-load natin si heart.test. Tingnan natin kung mag-work yung model natin. Okay, if it will work dun sa the model that we generated using heart.train. Let's see if it will also work. It will perform comparably or better, no? Yung sa testing data natin. Okay, so any questions about yung VCD Extra na ginamit natin? Nakuha nyo to? So there are
Sir,
7...
hindi ko siya na-install.
Hindi na-install si VCD Extra?
May message siya na,
Okay, sige, stop share. Tingnan natin,
yes,
ha?
sir.
Let me see. Anong sabi? Nagpapakipot ba si VCD Extra? Okay, R-Tools is required to build but it's not can. Sige, pag ganyan, i-install mo nga muna si R-Tools.
How? Ano, sir, ilalagay ka?
Sige, install that package.
Sir,
Yes?
parang po, VDC kasi yung na-type niya yata.
Ay, VDC pala.
VCD, dapat. Sige.
Sige. Try mo nga muna bago mo install si R-Tools. Try mo na VCD. Thank you,
Like that.
Ayan, sige. Ayan, mukhang okay na. There. Alright. Sige, tapos, Sige, yung ano na,
Tapos
yung
library na, sir.
i-library mo siya, no? And then, pwede natin magamit yun sa share screen na ako, ha?
Yes, sir. Sige. Stop
Okay.
share na po ako.
And then we can now use that for this function, yung data sets niya. Tapos, pinapa-generate natin kung anong data sets ang laman ng package na FF3. Okay?
Sir, may nakuha kong warning.
Anong warning? Ano sabi?
VCDX was built under R version 4.2.3.
Okay lang yun.
Loading required password.
Sa akin din, sir.
Pero nakuha nyo to? Yung rinan nyo si datasets? Kasi minsan yung mga packages, hindi kagad siya nag-update, no? So si R, nag-update. Tapos yung mga packages minsan, they need also to update in order to be able to, yung functionality siya magamit din sa current version ng R. So minsan kapag may mga conflict, nag-warning si R na yung VCD na yun, it was created for version like this of R. Okay, so pag ganyang situation, pwede mong i-run yung R na ganun version. Or, tingnan mo kung may package na na pag may functions na talagang kailangan in that package, then baka kailangan mong, kasi pwede ka naman mag-run ng R na yung lower version. That's possible. Okay. Try nyo nga muna, nag-run ba to?
Sir, sa akin lumabas yung kaninang pinakita nyo. Yung
Yeah,
mga
yun,
items.
yun ang gusto natin, no?
Mhm.
That's what we want, yung ma-output yung, ito, yung mga datasets na available dun sa FF3s. Kasi what we want to see here is that you can make use of data. And if you really want to learn about that specific package, and then go, kasi yung documentation yan, minsan may mga may examples, di ba? You have seen that sa help guide ni R, may mga examples eh. Tapos may ginagamit na data. And that data comes from the packages that are loaded sa R, no? Tulad nito, no? Andiyan yung Titanic. Andiyan yung Iris data, very famous data, no? Yung wine data din, 6,497 rows, no? Of observation, tapos times 13 variables. Okay? All right. So, sige, good. So, at least nakita natin. And as I mentioned a while ago, what we're going to use is this heart.test and heart.training. Training. No? All right. So, we won't do this help function anymore kasi nauna natin. So, let's load first. Tingnan natin data natin. Okay? So, maybe let's call it, anong gusto yung tawagin natin? Heart, ano? May pangalan naman siya, no? Yung heart, gagamitin natin si heart, heart training. Okay. So how do we load that? Paano natin siya ilo-load? Okay, we can of course use the data. Data heart dot train. Yung training data muna, no? Ay. Want to see the environment. Yan, okay. So makita yung environment natin. Alright, i-remove ko muna to, ha? Okay. Alright, so let's access first yung heart.train data. Now we can access this kasi na-load na natin si FF3s. It's already loaded. So any data set that come with FF3s can already be accessed. There. Wait. Na-load ko na ba si FF3s? Hindi ko pa yata na-load si FF3s. Okay, na-load ko na. And then, tama naman to.
Sir, baka heart train yung sa akin. Walang dot. Para ma-load yung data.
Ganun? Wait, ha?
Tinanggal ko yung dot. Na-upload yung
Bakit? Ang data nyo dito, heart. Ayan o, heart.train yun. Ayan, heart.train. Heart.train.
Parang may drop down siya, sir, ng option na heart disease pag sa FF3s.
Heart disease, pero iba yun eh.
heart train now, sir. Sa akin.
Heart train. Wait, let's see ha. Kasi, surprising. Agagamit ko lang nito eh. Heart train. Pero wala naman siyang heart train dito. Heart.train siya eh. Sige nga, let me see. Kung i-view ko, bakit ganun? Ngayon ko lang na-encounter to ah. Okay, sandali ha. Kung i-view ko siya kagad. Okay, or let me give it a name. Heart. Bigyan ko nga ng pangalan. Di ayaw din, no? Pero pag rinan mo to, yan to ha. Yan no? Heart.train. Heart disease training data. Subset siya ng heart disease data. Mas yung heart disease kompleto, ito sinubset siya. Oh, strange. Ganun nangyari sa akin to. Load ko ulit siya, no? Na-load ko na eh, di ba?
Sir, try mo. Tanggalin mo yung dot. Mag-load yan.
Pero tataka ko kasi tingnan mo, usage niya heart.train. So bakit ano? Bakit? Okay, subukan ko ha. Nag-load siya, pero let's see. I-view ko. View. Heart_train. So, nagkaroon ako ng heart.train dito. Pero yung heart train, wala. Ba't ako nagkaroon ngayon ng heart.train? Ito, look at this. No? What I try to generate is data heart train. I gave it a name, heart_train.
Ganyan din sa akin.
Pero
Nagkaroon ng heart train.
Oh, pero nagtataka ako kasi heart.train ang pangalan niya, di ba? No? Can you see, class? I was trying to, sabi nga ni Tim, tanggalin natin yung dot, no? So we remove the dot, tapos view natin yung object natin, ito. Pero itong object na to, ano siya? It's just a character, no? Heart train lang siya. Hindi siya ito. Kasi iba to, no? Alright.
Sir, sa akin, error pa din, sir, kahit ano.
Yung heart.train?
Yung sa heart.train, yes, sir, kahit na tinanggal ko yung dot.
Sa akin, sir, gumana naman. Yung tinanggal ko yung dot.
Ganun. Dali i-delete ko ulit to Delete ko siya lahat. I-room ko siya, no? Sige, uulitin ko to. This time, una muna yung regular, no? Okay, data. Tapos, ano nga to, FF. Buwan ko to Ayan. Ayan ha. Ginawa ko, data, tapos pinasok ko yung package and then double colon so that it will generate lahat ng mga functions na makikita natin kay FF3s. Okay, so this is what I did. So yan, FF3s, then colon, colon, and then heart.train. Let's see what happens. Okay. Allah. Bakit? Not found. This is weird. Sa totoo lang, class, kagagamit ko lang nito the other day. Ginamit ko itong data na to. I was discussing with another class. Itong data na to. Pag tinanggal ko yung data, ayun. So tanggalin natin yung yung data, no? FF3 lang na pero lalabas siya dito. Pero hindi siya nag-register dito. Let's call it heart underscore train. Let's give it a name. FF3. Okay. Tignan natin ha. So, nag-create ako ng object heart underscore train. And it represents the data set coming from FF3s na heart.train. Okay, tignan natin. Enter. Ayun, nag-create na siya. Ayan. Okay, so ganun na lang, no? Pero strange, eh? Ganito gawin natin, class. Let's create a data called heart underscore train. Pwede rin heart.train para pwede rin naman yun, no? Kasi pangalan naman ng object ko. Sige, gawin natin heart.train. I-delete ko na muna to. Okay. So I'm creating this object heart.train and it's from the FF3's package and the dataset heart.train. Okay. So run ko to. Ayan, meron na tayo dito. Okay, sige nga class, and please tell me kung we were able to generate. So team kasi walang walang parang highly unlikely na makaka-access tayo ng data na heart train na wala naman siya dun sa Okay, let me show you. Again, FF3s and FF3s. Oops. Colon, and then heart. Okay, if you take a look at heart, ay, wala. My heart.cost, heart.test, heart.train, apat lang eh. Apat lang heart niya eh. Walang heart train eh. So if I type heart train, error, oh. Heart train is not an exported object from the namespace FFPs. Okay, so just to remedy that, here we're creating an object called heart.train, and then see heart.train, it's coming from the FF3's package, and then specifically the heart.train dataset. Okay, so kindly chat please if you were able to access the data. Okay, thank you. Rap, thank you. Kung okay na. Ken, okay.
Yes, sir.
Alright, sige. Jonah, ikaw, meron na?
Yes, sir.
Okay, good. Okay, so let's first take a look. Let's study our data first. Tingnan natin kung anong laman itong... Okay. 14 total columns. No? So we have here 14 variables. A data, tingnan ko dito yung usage natin. Heart.train containing one. Tingnan natin yung yung see heart disease for details. So ano yung mga laman niya? Andiyan yung age, gender, chest pain is CP. And then resting blood pressure in mercury millimeter. upon admission to the hospital, cholesterol, fasting blood sugar, and then ano pa to? Mga ECG, no? Breast ECG, maximum heart rate achieved, etc. So there are 14 variables all in all. Okay, yung una, diagnosis, true value of binary criterion. True is equal to my heart disease, false is no heart disease. Okay, so ibig sabihin nun, the diagnosis, yung mga patients na to, with their ages, their gender, when they went to the doctor, to the hospital, kinuha yung mga data na to. And then ang conclusion based on the data is that false means, ano yung false? No heart disease. So okay to. Yung true naman, may heart disease. Alright? So what we're going to do now is we're going to model. Ipipredict natin yung diagnosis given these parameters. Okay, kasi itong false, ibig sabihin nito, di ba? Ano to, no? No heart disease. This person is 44 years old. Ang zero niya female. Chest pain, no chest pain. Resting blood sugar ba to? Blood pressure, BP. Resting blood pressure, okay? 108, etc. So ito yung mga details. Now, ang prognosis ng doktor is, diagnosis is false, ibig sabihin zero, ibig sabihin no heart disease. Okay? Pag one siya, pag true siya, may heart disease. Okay, so let's do that. Let's now make use of fast and frugal trees in order to ano natin, no? I-create natin yung model natin. Okay. Sabi natin, ang main, okay, sandali Sorry, naglolo ko lang tong ano ko. Okay. So, okay, the key variable natin that we want to predict is diagnosis. Okay, this is false. Kung false siya, is equal to 0. So, walang heart. Having heart attacks. Tapos yung 1 naman, yung may heart attack or may heart disease. The goal is to be able to find a few key variables in the data that can quickly and accurately predict diagnosis. Okay? So gusto natin, okay. Alright, so mag-create tayo ng object na heart FFT. Let's do that, heart underscore FFT. Alright? Tapos, gagamitin natin balikan natin tong packages natin. We're going to use this main function FF3s. There. Okay, tapos ito yung syntax niya, no? Ito yung syntax niya. Alright. In fact, I think, okay. Alright, sige, let's first, ang ano natin will be yung formula natin. Ano yung formula natin? What will be our formula? Lolo ko talaga itong ano ko, sorry guys. Ang mouse ko medyo slow siya. Alright? So, as we said here, yung pinaka-main workhorse ng FF3 function package is itong function na to, FF3s. Alright? So yung una is, the first one is Sorry, medyo nagloloko crash yung ano ko yung mouse ko. Okay. Formula. Ano yung formula natin? Parang regression lang to. Control tilde. Ayaw na naman. Okay. Shift pala. Shift tilde. Have you used R sa multiple linear regression? Sa multiple linear regression sa R, ang ginagamit natin yung tilde, no? For, wala pa tayong mali na naman yung spelling ko. Okay, wait. Nalolo ko kasi ang aking mouse. Formula is equal to, so si diagnosis, yung ba yung natin, variable natin? Okay, diagnosis. Okay? Tilde, ano yung tilde sa ano? Nakagamit na ba kayo ng regression using R?
No, sir.
No? Okay.
sir.
No, sir.
Pag nagre-regression kayo sa R, ganito, no? Bali, ganito yung formula. Bali, LM, yan. Tapos DV, independent variable, tilde, okay? And then, variable 1 plus variable 2. Pinapakita ko lang yung basic function. Okay? And then data is equal to kung ano man yung data, no? Okay, so this is the generic formula ng linear regression model sa R. So, simple lang. LM, linear model. And your DV is whatever your dependent variable is. And then regressed on, ito yung mga variables niya. Ito yung mga independent variables. Variable 1, variable 2, variable 3. No? And then data is equal to whatever the name of your data is. Now, if you're including all your variables as your independent variable, except of course your dependent variable, pwede mong gawin yan, i-replace mo to ng dot. Ganyan. So, R will read it as yung dependent variable natin, okay, regressed on all the other variables. Yun ang ibig sabihin yan. Shortcut siya. No? And data is equal to X. So, ganun din dito. We're going to regress diagnosis on all your variables. That, yan. Yan. Dapat dito. So, I'm going to put here that and then comma. So, tapos tatanggalin ko itong parenthesis na to kasi may continuation pa to. Alright, so yan ang first line natin, no? So, ang function natin FF3s, and then we write the formula, diagnosis regress on all. So, if you take a look at heart train, ito yung natin, ito yung dependent variable natin. So, you're going to predict 0 or 1, 0, no heart attack, 1, yung true with heart attack, using age, sex, chest pain, etc. So you have 13 predictor variables. Okay. All right. So, so the variable being predicted is diagnosis. All right. Ano yung training data natin? So we have to define data is equal to heart dot, heart dot train. All right? Comma. And then dito, we will have to define the, sorry. And dito yung comment natin, no? Training data, and then here, okay, we have to put data dot test. Our testing data is, okay, yung heart dot test. Heart dot test. Ito yung syntax ni heart dot test, comma. Okay, lagyan natin ng label yung natin. We can put a label to our yung natin, yung plot natin. We can call it, yung main label natin is equal to emergency, sabihin natin emergency room decisions. Okay, and then Yung decision labels natin, pwede natin ilagay decision dot labels, yan. Yan, decision dot labels from FF3s. Ano ilalagay natin? Combine natin si kapag zero, stable, di ba? Or no heart attack. Ilalagay natin. Say stable na lang. Stable. And then, kapag 1, with heart attack. Okay. Right? So, para makita natin yung stable at saka yung may heart attack. Okay, so let me explain this again. So, dapat may opening to. Kita niyo, may pula dito. Ano? Ibig sabihin, may kulang ako ng closing. I have to close that. There. Nawala na. Okay. So, we're creating this object. Ito yung model natin using FF3s, fast and frugal trees. And the formula is we're regressing diagnosis on all the variables. And we use that for our training data, its data is equal to heart.train. For our testing data, its data.test is equal to heart.test. And then our main, yung main plot natin will have a name, emergency room decisions. And then ang decision labels natin, yung stable and heart attack. Okay, yan ang decision labels natin. Okay, so let's run this. Run. Okay. Okay, so nag-run na ba sa inyo? Nag 100% na. Okay na. So it tells us successfully ranked 13 queues, successfully created 7 FFTs, successfully defined 7 fast and frugal trees, successfully applied FF3s to trained data, successfully ranked FFTs by trained data. Okay, so pinapakita niya yung mga success na ginawa niya. All right? So what kind of data is tingnan mo natin tong Let's see what this. So it's a list, no? It's a list consisting of this. Andyan yung criterion name, andyan yung queue names, yung mga independent variables. Andito si formula, tingnan natin formula. Right, diagnosis. Okay, andito yung trees din. All right. 7 daw yung trees na nagawa niya. All right, and others. So maraming laman tong heart FFT nito. Okay, so let's take a look now. Tingnan natin kung anong laman niya, no? So print na natin heart underscore FFT. All right, let's print. Okay. So what do we have here? Okay. Nung print natin, tingnan nyo class, no? So tingnan natin to, Emergency room decisions, ito yung title natin, using FF3s. So it created 7 fast and frugal trees predicting diagnosis. Okay, and then we have this one, outcome cost. Okay, we have this metrics. We'll go back to this, no? Kasi explain natin kung ano yung high, ano yung FA, ano yung MI, at saka ano yung CR. Okay, so let's go here first. Ito yung ito yung process niya. So it started with this one. Ano yung thal? Okay, na-define na kanina yan, okay, wala dito. I forgot the thal. Okay, anyway. So, variable yan, Tapos, ang sabi niya dito, if thal daw is equal to RD at saka FD, tinan mo natin yung heart rate. So, ito si thal, no? Ito to, yan. So, categorical siya, no? Factor, in fact, may normal, may RD, at saka FD. So in order to understand this more, titingnan natin yung metadata, no, about tinignan natin kanina, but I forgot what that thal means, no? Okay, so whatever that means, ang sabi dito sa model natin, if thal is equal to RD and FD. Okay? Pag RD and FD daw, decide heart attack yan. Heart attack yan. Tingnan ko nga, sorry heart that train. I just want to see yung metadata niya. Alright, here. Okay, ano yung thal? Normal, FD fixed defect. Okay, hindi na in-explain, no? Kung ano yung thal na yan. So anyway, let's just take it as it is, na normal siya, fixed defect, or reversible defect. Okay, so pag thal daw is equal to RD, reversible defect, and fixed defect, heart disease kagad yan, heart attack kagad yan. And then next, if CP, chest pain yata to, is not equal to A, then decide stable. And then if CA is greater than 0, then decide heart attack, otherwise decide stable. All right, ito yung tree niya, no? So this is what it's saying. So if you take a look at these 3 steps lang, if thal is equal to RD or FD, then heart attack yan. And then if CP is not equal to A, then stable yan. Ibig sabihin, pag A yan, si CP, heart attack yan. And then yung CA naman, if CA is greater than 0, then dapat heart attack siya. Number of major vessels, okay, colored by fluoroscopy. Okay. Alright. So tingnan natin, ano nangyari dito. There are 150 observations sa training data natin. Okay? 150 observations. Alright. Tingnan nga natin kung asan ba yung natin? Training natin. Ito. Let's see. Can we create a table out of that table? Let's see. Table heart that train dollar diagnosis. Okay, yan. So ito yung ito yung distribution niya. False, ibig sabihin walang heart attack, walang heart disease. 66 yung may heart disease. Alright, so this is the distribution ng 150 data set natin. Okay, 84 ang may heart disease, 66 yung 84 yung walang heart disease, 66 yung meron. Okay. So, tingnan natin yung breakdown niya, no? Alright, ito yun, no? N is equal to 150, ang positive dito is 66. Ito yun. Which is 44% yung positive yung may heart disease. Therefore, 56% yung 84, yun yung negative siya for heart disease. Okay, and then take a look at this. No? So this is now yung true value, yung true data. No? Okay, true na plus, ang ibig sabihin ng plus, yung may heart disease. Okay, that's 66. And then, true na minus, that's 84, which is this one. Ang yung totoong walang heart disease, 84. Yung true naman na may heart disease, 66. Okay, so this is the actual data. No? Ito yun. Alright. Now, ano to? This is now your prediction. Predict dito na may heart disease siya. Alright? So, ilan yung ang predict niya na may heart disease, 54 lang. So, predict niya na walang heart disease, 12. Okay, so out of 66 na may heart disease, 54 was correctly predicted and 12 was not. Okay? Yun ang ibig sabihin nito, no? Yung decide dito is the prediction. Alright, so andito si HI, si MI, si FA, at saka si CR. No? So, ito yung mga meanings niya, no? Yung tamang pag-predict na may heart disease, okay, ito yun, no? Tamang pag-predict na walang heart disease, that's 66. Okay. So, predict niya na na may heart disease, 54 yung tama. Okay, 18 yung mali. Predict niya to na may heart disease pero wala naman. Okay, clear ba yung class? So this is your misclassification table already, no? So generate na siya ni Fast and Frugal trees for us. So kita natin dito yung predict niya na na may heart disease. Okay? Sorry, minus to. Predict niya na walang heart disease pero meron namang heart disease yun. So mali ito, no? So the red ones are those that are mistakenly predicted, while the green ones are those that are correctly predicted. So you can see here that 54 plus 66. Okay, 66. Ito yung tama na predict, no? Divided by, okay, I have to put a parenthesis here. Okay. 54 plus 66. Okay. Divided by, ilan lahat ng observations? 150. Okay, so ang accuracy rate niya is 80%. Ito yun. Ito. Okay, meron pang ibang measures dito like sensitivity, specificity. I want you to find out paano nakuha itong mga to. No? So this is an interesting study. So there are several metrics that we can use in order to assess the performance of our model. Okay, using the training data, 80% were correctly predicted. Eh, tapos may levels pa yan dito, no? Dito. So dito, alright, dito, 54 were correctly specified. Dun sa mga 66, no? Dun sa mga may heart attack, 54 yung tamang prediction out of the 66 na may heart attack. Okay? So nakikita nyo to 0.2, no? 80.2%. Alright, ito yun. Okay? So I'll leave you to explore this first and then babalikan natin to next. I want you to know, saan to? Ano itong sensitivity na to? Okay, sorry. Yung sensitivity is this one. Okay? It's the proportion of the correct prediction for the one with heart attack. 54 out of the total na may heart attack, 66. 54 yung tama niyang na-predict. Okay? Dito naman, yung predict na walang heart attack, 66 yung tama. No? Out of the ilan lahat yung walang heart attack? Divided by 84. Okay? So that's 0.78 point. Saan siya? Ito. No? Ito yung specificity and then yung sensitivity and specificity. Okay, I'll leave you to discover what the others are. All right. Then, okay. May iba pang measures dito ng frugality. Hindi na natin titinan yung cost na yan. No? Okay. Now, what we can do is we can visualize this. Okay naman to. No? Okay naman to, but it doesn't give us the whole picture. So let's now visualize. And we can use the plot function. So sige, i-plot natin class yung i-plot natin yung FF3s natin na na model. Okay, so how do we plot it, class? Paano? Plot lang. No? So plot yung object natin si FF heart underscore FFT. There. Heart underscore FFT. So ipa-plot natin yan. Tapos, We have to identify the data. Ang data natin, data is equal to yung train data natin, no? Heart.train. Okay? Okay. Ano lumalabas, class?
Emergency room decisions, tapos meron siyang
Hmm?
parang flowchart.
Yan. Alright. Ito, di ba? Take a look at this. Ito na yung plot, ito na yung dinefine natin kanina, no? Let's take a look at this. Alright? So let's just study this briefly. Ito na yung emergency room decisions natin. Parang hindi clear yung ano. Mas clear pa pag nakaganito eh. Pwede ba maano to? Yan. Okay. Pag malaki kasi parang hindi maganda. Kita ba, Kas? Ayan. Okay. Alright. So, what do we have here? What do we have here? Ito yung probability ng ano ng stable, no? Stable. Saan ang galing tong 56% na to, class? Where did this come from? This one. Anyone? Oh, we already showed this a while ago. Kanina. Okay, balikan natin. 'Di ba nung create natin tables? Saan yan?
Siya yung 84 kanina, sir.
84 at saka
84 over 150.
ilan yung total natin? 150, di ba?
150, yes, sir.
150. Tapos ilan yung ano? Ito, andito siya. Ayan. No? Ito, di ba?
66. sir.
Ilan yung may heart disease? 66 out of 150. So ilan yun? 44%, right?
44%, yes.
Therefore, of course, the other one,
Yung opposite, yung stable.
yung stable should be 56%.
56.
Kasi 100% yun. Yun, yung kanina, no? Yung, okay. Alright? 56% stable, 44% heart attack, no? So ito yung data natin, 150 observations, of which 84 are stable, 66, kita nyo to, class? Hindi itong portion na to. 66 experienced heart attack, 84 were stable. Okay? This comprises 56% yung stable, and this one is 44%. Okay? Alright. So, yung predict na ano na stable, okay, the green one pertains to correct prediction, the red one pertains to wrong prediction. Okay. So let's take a look at this. So nagsimula siya sa ano, yung thal, sinimulan niya yan. If it's equal to RD or FD, di ba? Ito yung parang ano, tree diagram na natin, no? Decision tree na natin. If the thal is equal to RD or FD, then heart attack na siya. Okay? So dito sa steps na to, sa level na to, when this was applied, okay, heart attack, di ba? So, 47 were correct. No? Dito sa first ano pa lang, sa first stage na to. 47, tama yung ano, using this parameter. 16 yung mali. Ibig sabihin, meron doon mga RD o FD, there were 16 all in all, that what? That did not really that did not suffer heart attack. So merong 16 doon. Okay? When this was applied, tinignan muna yung mga RDFD. Okay? So ilan lahat yung may RDFD sa TAL? Ito yon. 63 lahat yon. Okay? 63 siya lahat. Ilan ba to? 16 plus 47, that's how many?
63, sir.
63.
63, no? 63. Doon sa may 63 na may RD at saka FD, 16 yung hindi naman nagka-heart attack, no? Right? 47 yung nagka-heart attack. So ibig sabihin, 47 were correct predictions, 16 were wrong predictions. Okay. So punta naman susunod dito. So if you trace this, kaya nga sabi natin yung decision tree, it mimics no how we think yung human brain. We split it first. Ito muna, TAL equal to RD and FD. So meron na tayong mga ano dito, may classifications na tayo dito. Then we go here to CP. If CP is not equal to A, ito naman nangyari, no? May prediction sa dito. Okay? Kasi pag sinabi natin if CP is not equal to A, then dapat stable siya. Okay, of which dito sa 63, ito, if you add 55 and 8, that's 63. So sa 63 na hindi equal to A, okay, hindi siya equal to A, 55 doon yung stable, pero 8 doon, yung hindi equal to A, hindi siya stable, may heart attack siya. So this was the wrong prediction. Okay, then punta na naman dito. Next, ang CA is either less than 0 or greater than 0. Then it splits the three further. Okay, so if you take a look at this, ano to mga to? You have correct prediction here, 55 at saka 11. So what's 55 at saka 11? 55 at saka 11, di ba 66? Di ba ito yun? Di ba? Yung predict niya na stable. Okay? Which were actually stable. 66. Pero may predict din siya na itong 8 at saka 4, predict niya na hindi stable. Okay? Predict niya na may heart attack to. When in fact, stable dapat to. Yung 12 na to. So tingnan nyo. Napunta siya dito, no? Right? Tama ba, class? Or nalito kayo sa pag-explain ko? The truth is, itong 12 to, ano sila?
False.
Ha?
False prediction.
Yung 12, ito? Pag false kasi, yung truth, predict siya na stable, di ba? Itong 63 na to, predict to na stable. Ito. Pero, yung 8 doon, hindi stable. Right? So may mali siya, may mali siyang prediction. Tapos dito din, ganun din. Okay? Predict niya na stable. Right? Pero hindi naman siya stable actually. Yung reality, yung truth, hindi siya stable. So dito may maling prediction. No? Predict siya na stable pero hindi siya stable. So ilan to? 12. 8 plus 4, 12. So ito yun, no? This one, 12. Diba? This 12. It was predicted to be stable. Ito, stable, stable. 8 plus 4, that's 12. Predicted as stable. Pero, actually, nagka-heart attack yun. Diba? So ito yung mga maling predictions. So itong 12 at saka si 18. Okay, if you can see here, 16 plus 2. Okay, 16 plus 2, that's 18, no? So maling prediction yan. Ito yun. Kasi predict niya na may heart attack. Ito yung mga prediction na heart attack. ito yung prediction na stable. So, dinivide natin. Yung mga predict niya na may heart attack, tsaka predict niya na stable. The red ones here are those that were predicted to have heart attacks, but were in fact stable. So ano yung mga mali na predict niya na may heart attack, pero actually stable siya? Ito. Sa phase na to, 16. Dito naman, 2. So 18 yung mali niya. It was predicted to have heart attack. May heart attack prediction, pero stable siya. Okay, so this is the error here. 16 and 2, that's 18. Ito yung error. Ito naman, yung 12 na to, saan yun? Predict na stable siya. It was predicted to be stable, yan. Stable here. Predicted to be stable. When in fact, it was not stable. So 8 plus 4, 12 yun. Ito yun. Ito yung wrong predictions sa model natin. Okay? And then ito na naman, si sensitivity, si specificity, si accuracy, and then the other metrics, no? Sorry, nakalimutan ko lang yung, I can't recall it now, no? Yung mga meanings ito, no? But I'll just have to review that. Nasulat ko na yun eh. Okay, and then this one, ito yung receiver operating curve. Ito. And it plots the specificity and the sensitivity, and then it compares the different models that can, the different models, no? Andito si support vector machine, andito si random forest, andito si logistic regression, andito si ordinary cart, yung decision tree, andito si fast and frugal trees. Okay? So here, you have here a plot of your, ito yung number 1, si FFT, a plot of your sensitivity and your specificity. Okay. So ano ibig sabihin ng number 1? Number 2, so nakarank siya, no? Nakarank. So in terms of the ROC, okay, the FFT outperformed the others. Despite the fact na ilang variables ang tinignan niya. Ang tinignan lang niya si TAL, CP at saka CCA, di ba? Of the 13 variables na given dun sa data, okay, si fast and frugal tree, pinilan lang niya yung 3. Okay, in fact, it can outperform logistic regression, random forest, SVM based on this ROC. Okay? All right, so let me go back there to our model. Okay. So ito yung ito yung niya, yung decision. Ito yung decision tree niya. So 3 lang yung Qs natin, no? Yung TAL, yung CP at saka yung CA. Others call it variables. 3 lang yung variables ang tinitingnan natin. As soon as a decision is made for a patient, then no additional information is considered. Okay? Kung nakapag-decide na about the status of a patient, okay, hindi na kailangan ng additional information about that. Kumbaga, parang final na yun. Okay, then a little explanation here. All right. Okay, so medyo may konting explanation ako dito, no? Okay. And then, I'll just leave you to okay, ito yung sinabi ko kanina, no? FF3, represented by the green circle 1, had a higher sensitivity than logistic regression and random forest. Okay? But at the cost of a lower specificity. So if you take a look at that, ito, no? Ito kanina, no? So prinat yung sensitivity and then yung specificity. Okay, you can see here, saan mas mataas si FFT and saan siya mas mababa. Okay? Lower in terms of specificity as far as number 2 is concerned. Sino ba yung si number 2, si number 4, at si number 7? But higher in terms of sensitivity to 3, 5, and 6. So we have to look at the definition of sensitivity katulad ng sinabi natin kanina or specificity in order to fully understand this plot. Okay, so all right. Now, kanina kasi ang ginamit natin si training data. Na paano mag-work kaya to? Ano kaya mangyayari kung if we use this data, if we use this model for our testing data? Okay, so what will happen? Di subukan natin, no? Pwede na tayong dumiretso sa pag-plot. If we plot, ano yung plot natin? Si heart underscore FFT. Alright? But before we do this, tingnan muna natin si si data. So, heart dot testing data, FF3s, and then heart dot test. Okay, let's load heart dot test. Okay, so mas marami mga observations si heart dot test. So this is heart dot test. Similar data, similar lang, but this is a data that has not yet been seen by the model. Hindi pa niya nakikita itong data na to, no? Okay, let's try to see this. So i-plot natin, plot. Ay ko na uuna si FFT. Si heart. Anong pangalan ng model natin? Sorry. Medyo nalulobat na ako. Sorry, class. Sa totoo lang, nadedrain ako sa traffic kasi pag Wednesday, nanggagaling ako sa Lasal. And sometimes I have to be there ng minsan, maabot na ako minsan ng past 5. So I have to really hurry back. Antipolo pa. No? So talagang nakaka-drain yung travel time. Okay. So yun yung natin, di ba? Ito yung model natin. And then, ang data natin is equal to heart.train. Okay. So here, we're going to i-run natin yung, may coach ba yun? Wala naman, no? Wala. Wala siyang coach. Okay. So let's see if our model, if our model will perform good even if we use the model for a data set that has not yet been that has not yet been seen. Di ba? Ang ginamit natin dun sa FF3's function natin is to use the training data. Okay? Now, ipapaplot natin yung data natin, ipapaplot natin yung model natin, but this time, ang gagamitin niya yung heart.test, yung testing data natin, which has more, ilan ko nga ulit to? Table, okay, kunin ko yung diagnosis, okay, galing to sa heart dot test, okay, $. Alright, heart dot test, yung diagnosis variable, ipa-create natin yung table. Okay, here, 152 to, no? 153 respondents. 80 were diagnosed as no heart attack, no heart disease, while 73 were diagnosed to be having heart disease. Dito sa sample na to. Okay, so if we run this, Okay, di ba itong heart FFT na to, saan galing to? This is the model that we use to predict yung diagnosis using the heart.train data, yung training data natin. Ito yun. Now, we will see if I'm going to use that model to a data set that it has not yet seen. Kasi yung heart._FFT na yan, na-generate and using the training data. No? Pero ito naman, gusto natin i-test, okay ba siya for a data that has not yet been seen. Run natin to. Okay, let's see. Okay, did it perform better? Let's see. Okay. All right, tingnan muna natin. 64 out of 60, 64 plus 61, okay, that's 125 divided by, against 18, against 28. So, accuracy niya is 82. Di ba? So, was there an improvement, class? Nag-perform better ba yung model natin dito sa data set natin na hindi pa nakikita?
Same lang, sir.
Same lang ba? Ilang percent ba yung sa ano? Sa kanina?
Parang 80 kanina, sir, yung accuracy.
O, 80 kanina, di ba?
Yes.
Wala kayo sir.
O, 80 kanina yung accuracy. Ito, 82. And
Slightly better.
Yeah, slightly better siya. Despite the fact that this data was not yet seen, no, by our model. Ginamit natin yung model, the one that was generated using the training data. Ito ngayon yung gamit class ng yung sinasabi natin overfitting, no? But that's why we don't use the yung whole data, no? Kasi mag-overfit tayo kasi pag may new data na, 'di ba? Hindi na niya ma-recognize yung new data or mag-model pa rin niya, of course. But however, it has modeled pati yung noise ng data na ginamit natin. So that's why it performs poorly. Now on Saturday, pagkatapos natin discuss yung portfolio analytics, discuss natin yung random forest at saka yung cross validation. Kasi I'm excited to discuss with you that topic kasi yung cross validation, that's a very powerful tool to really generate very good machine learning models. Ito nga ang ginawa lang natin, di ba? Ilang testing data ang ginawa natin? How many testing data did we use? Only one, di ba? Yung heart.test lang. Sa cross-validation, hindi ganun. Ang gagawin ni cross-validation, okay, ang gagawin niya, yung separate na data, so yung data na gagamitin natin, kukuha siya ng sample dyan. And then several samples, depende kung anong gusto nyo. We can ask R to generate, let's say, 1,000 samples. So imagine, mag-create siya ng model using different data from that data set. So gagawa siya ng mga subsets on that. Tapos i-run niya. Gagawa siya ng maraming models. Okay? And that's your cross-validation. I-discuss natin sa Saturday. Kasi yung cross-validation yan, that's a very powerful tool to address yung overfitting. Okay? All right. So here we can see that na-outperform pa niya yung yung na-outperform pa niya yung training data, which is ano ibig sabihin nun? Na napaka-powerful ng model na to. Okay, mas mataas pa yung yung accuracy dun sa testing data. Okay. So let's end in this. Tapusin na lang natin to, konti na lang naman Ito na lang to, no? All right. Just 1 or 2 cones na lang to. Now, the best thing with FFT is that we can ito kasi siya nag-generate, no? Pero kunyari, may ano kaya, meron tayong prior knowledge na dapat ito yung ano, dapat ito yung ano natin, ito yung process natin. Okay? So, paano yun? Paano kung ano, paano kung ito yung process natin? If cholesterol is greater than 300, decide heart attack. If age is less than 50, decide stable. If slope is either up or flat, predict attack. Otherwise, predict stable. Okay. How will we do this? Okay, so in the interest of time, kasi medyo tatagal pa tayo, ano, kung ano, let me share with you the code for that, no? So ginawa ko na to. Okay. So this one, X ko na muna siya. Okay. Okay. All right. Okay, take a look at this, class. So pareho pa rin yung formula natin, diagnosis regressed on all the variables. Ang data natin, yung heart.train natin, ang data test natin, yung heart.test, and then magmo-modified tree tayo. Ano yung idadagdag natin? Ito. Idadagdag natin dito that my.tree is if cholesterol is greater than 300, predict attack. If age is less than 50, predict stable. And if the slope is equal to up or flat, then predict attack. Otherwise, predict stable. So ito yung sinasabi natin na pwede nating, we can change yung output na ibibigay ni FF3s by defining our own steps. No? Ito sinasabi, kapag ang cholesterol dapat 300, predict attack mo na yan. No? Kung less than 50 yung age, pwede nating sabihin, example lang to kasi ito naman parang it's not necessarily na less than 50, stable yan. Eh. Kasi meron tayong mga instances na batang-bata, di ba, namamatay sa heart attack. Diba? Okay, if slope is up or flat, then predict attack. Otherwise, okay, lagyan natin dito para nasa isang line. Otherwise, predict stable. All right? So, let me share this with you para hindi nyo na-type. No? And then, sige, bigay ko na itong buon to. Dapat you're supposed to copy everything there from the above. Okay, sige. Let me just share with you this with you in the chat. Control-C. Okay, and then sa chat natin. Okay, chat. All right, Control-V. Okay. Kindly copy it, class, and then i-format nyo na lang in such a way para madaling makita. Okay, ito yung kanina hanggang dito lang tayo. We ended here. But as I said, we can modify our tree. Okay, to include this one. And my.tree is equal to this one, sinabi natin. Idagdag natin na kapag ang cholesterol greater than 300, predict attack, etc. All right. Okay? So custom natin to, no? Ang tawag natin dito, iba to sa kanina, no? Kanina heart_FFT, ngayon nag-custom FFT tayo. So let's run this. Okay. Alright, so medyo may ibang output tayo. Plot nga natin, class. Okay. Dito, ang gawin muna natin yung sa muna. Kasi ibang na to, ibang model na to, no? Data is equal to heart dot train muna natin. Okay? So let's plot our custom FFT using the heart.train. Tingnan natin kung ano magiging result. Okay, so we have this, the same thing. And, okay, pangit ang accuracy natin. Kasi hinula-hulaan ko lang naman yan, no? 59 yung accuracy. So, ibig sabihin, hindi maganda yung ano, yung ginawa nating ano. Mas maganda pa yung una, no? Kasi ang ginawa natin dito, di ba? Yung cholesterol, sinama natin eh. No? Right? Asan yung cholesterol? Ito. We included cholesterol. Okay, pag greater than 30, heart attack yan. Pag age is less than 50, stable. Okay, pati yung slope, no? Pag flat, okay, stable. Alright, so ito yung naging ano, no? Ito yung naging parameters na ginawa niya, no? Yung ginawa natin, yung MY3. And then, okay, ang accuracy niya 59. So, we were not able to beat yung ano, yung kanina, no? Yung CFF3 mismo yung nag-generate. Okay? Right, kasi dinagdag natin to eh, itong MY3. Ito yung sinunod niya. Okay? Now let's see if kung yung isa, how about dun sa ano sa will it fare better dun sa test? Heart.test. Okay? Will this fare better? Plot natin, let's see. All right. Bumaba pa nga. Kanina 59%, no? The testing data, it was already 54. Okay? It was low class kasi inano ko lang naman to, no? Yung inimbento ko lang, no? So, of course, doctors would know better. Kung sila gagawa nito, maybe they'll be able to suggest ano ba dapat yung ano yung pinaka-primary na nakikita nyo na a factor for having a heart attack. Okay, so they can make their own model. No? Ito, ano lang tayo. Definitely, ito medyo ano naman, ano, medyo parang kung less than 50, predict stable kagad. No? Parang hindi naman yata makatotohanan. No? All right. Okay, so So as I said here, marami pang pwede magawa sa package na to, no? We can predict classes, their probabilities for new data sets. Okay, so inano lang natin, we just scratch the surface here. Ang importante dito, that we learned that FF3s will be able to create a decision tree using the most minimum of the attributes of the dimensions. Diba? For 13 variables yung binigay natin. Pero ang ginamit lang niya, 3. Yung TAL, yung CP, at saka yung CA. Okay? Tayo dito gumamit tayo ng 3, but of course, ang layo siya dun sa ano. So, ibig sabihin, itong machine learning tool na to, nakapag-create siya ng isang model na 80% yung accuracy dun sa training dataset and even 82% dun sa testing dataset, mas mataas pa. Okay? So, sabi ko nga sa sarili ko, Bob, better luck next time. Hanap ka pa ng mas maganda na dyan. Pero if I were to interview siguro a doctor and ask, among this, ano kaya yung ano? Gusto kong gawin yun eh. Hindi ko pa nagagawa kasi. But I would want to ask a doctor kung among this, kunyari, if he or she was to identify kung ano yung 3 or 4 na main na pwedeng gawing main criteria in deciding whether a person will have a heart attack or not, then tas gagawan ko ng model, then that will be interesting. Kasi iba't ibang, and of course, in real life, siguro, mas maraming parameters, mas maraming data na pwedeng gamitin to predict heart attack. Okay? So, next meeting, class, let's call it a day now. I hope you don't mind, class. Calling it a day now kasi I don't want also to extend beyond ano. Babawiin natin next meeting, no? We'll have we can make it okay, anong oras ba ako 6:45, will that be okay, class?
Okay, sir.
Sige,
Saturday,
6:45.
sir?
Saturday tayo, no?
Yes,
So
sir.
Saturday, ang first 1 hour natin sa portfolio optimization tayo. kaya natin 1 hour yun kasi yung pag-load natin ng data set, pag-compute ng mga returns, alam na naman natin yan eh. But I'm sure you'll also like us going from the beginning, no? 'Di ba? Mas gusto niyo 'yun, 'di ba?
Yes, sir.
Para yung full breadth ng ng portfolio optimization. Okay? And then after that, 1 hour yun, yung remaining we will do random forest. Isasabay ko yung random forest at saka yung cross validation kasi gustong-gusto ko ma-discuss sa inyo yun, no? Yung random forest and cross validation. And then may remaining sessions pa yata tayo. There maybe we can do support vector machines. Okay, and then your finals will be, medyo mag-isip-isip na kayo an application of machine learning in finance. No? So, hindi naman fully at liberty. You will have to first tell me what your plan is. No? And then I'll give you the go signal. Okay, the deadline for the case, which is your portfolio optimization, and your finals will be the same. Doon na sa sinabi ko, April 19 or April 20? Okay, basta along those
19, sir.
19 ba? O sige, okay.
Opo.
So I think that's enough not enough time. Kasi pag na-discuss natin yung portfolio natin sa sa Saturday, pwede nang gawin yun eh. Actually kaya ng 1 hour yan na sit down lang, 1 to 2 hours. That's more than enough. So okay na yun, no? Okay na yung case na yun. You can already I'll create the folder for you to submit that. So that's already done. Yung na lang, yung machine learning tool na lang. So yun na lang medyo magbabasa-basa ng konti, maghahanap-hanap ng konti na pwedeng gawin as a final project. Okay? Alright. So stop recording ko na muna. Okay.